So microservices themselves are actually an evolution. If you look at the Wikipedia page, you can actually see this like evolving in real time. But like as Randy sort of discussed in his keynote, we've been building these sort of things for a long time. So we started with like simple applications, 2-tier architectures, 3-tier architectures. These became N-tier architectures back in the sort of late 1990s. And services really changed that because rather than just separating things into layers, it involves separating things into services which have an individual responsibility. Something which does some very specific task that plays a role in the wider workflow. So for example, we might have an order service and a stock service or a basket service. So if we want to know the contents of our basket, we go to that particular service for that particular role. But one of the interesting things, so when we build these things originally, we would typically release them together, right? It's just one application, a bunch of different services, connected together, one application. Microservices is a little bit different for a number of reasons, but one of the most key differences is this independent deployability. So each service manages its own life cycle. And this is important because it allows us to scale. Not so much in the sense of scaling to like millions of users or petabytes of data, but it allows us to scale in people terms. It allows us to kind of break an architecture up into a bunch of different teams which can evolve independently. So just kind of to summarize the principles, we've got single responsibility, typically much more fine-grained, so we're looking for services where the software kind of fits in our head. That's kind of the goal. Modularized, which really means that a single business process will be the culmination of the actions of many different services, and then independently deployable and run by many teams. But when it comes to data, microservices tend to promote this notion of independence. Randy talked about this before. So each service will typically have its own database. And this makes a lot of sense because databases provide a very rich type of coupling. They're shared mutable state, and they have this like rich amplifying interface, which you get from the SQL language, which you interact with. It's a very rich surface area. So microservices typically avoid having one single database because of it forming this very tight point of coupling. But most business services share the same core set of facts. If you work in online retail, the customers, the orders, the product catalog, these are things that all of your services are likely to need. So in an architecture where we're inherently distributed and we have this single responsibility principle, it's often quite hard to get a joined up view. Our data lives in a whole set of different data islands. So we really want to have this idea of a joined up view. So I said that, I mentioned that microservices is really an evolution. And what I find quite interesting is what's going to happen next. I don't think we've actually solved all of the problems with this pattern yet, despite having been doing it for about 20 years. But we have learned a lot along the way. So in this talk, I want to talk about one view of what sort of microservices 3.0 would look like. So there's 4 kind of key tenets to this. Loose coupling being data-enabled, being event-driven, and having operational transparency. So loose coupling. If we build systems with synchronous protocols, requests and responses, this is a very natural way to piece a system together. But it leads to very tight point-to-point couplings. So coupling is actually a measure of the assumptions that 2 services make about one another when they exchange information. Or another way to think about it is it's sort of the surface area that a service exposes to the outside world, which other services can kind of couple themselves to. So if we have an architecture and we decide we want to change this particular service, we have to worry about every single thing, every service that depends on us and every service that we depend upon. So one route out of this is a technique called receiver-driven flow control. And if you use Kafka or any other message broker, this is something that you'll intuitively understand. It's just a fancy name for it.